Hello and welcome back to another video in my D3D12Ez video series here on the DirectX channel. In this video series we're going to do an ad hoc approach on DirectX 12 and basically just learn what we need to know to get DirectX 12 running without all of the fancy stuff that's not really required. Of course, everything dependency-less, just a plain old Visual Studio solution. Alright, so in today's video, we're gonna discuss the DirectX 12 device, the comment queues, and the concept of comment queues and comment lists, as well as the synchronization mechanisms between the GPU and the CPU that we need to execute comments on the GPU. Now this all seems a bit complicated now from how I've said that, but don't worry, I'm gonna go into all of the details and you're gonna understand how all of this works in a few minutes. But before we're gonna get to all of the fancy stuff of comment queues and comment lists, I wanna go into the core fundamental concept of a DirectX 12 device. Now what we have previously just done is we have just initialized a so-called debug layer. This is now a static instance, probably also a singleton for our application that has been basically created by Microsoft by obtaining the debug interfaces. And basically what they were doing is they were just doing some CPU-sided stuff that basically instrumentalize the API so that the API can do some checkings and notify us if we are doing something wrong as a developer and basically tell us what we have done wrong. Very powerful, especially this is something where I love DirectX 12 because the debug layer is enabled as easy as that. It's not that complicated as well. It is easy. Now, basically what we have done until now, it is just like some basic DirectX 12 infrastructure on the CPU side. We never have ever touched the GPU yet. But that's something that we want to do today. Today we want to actually now open up an interface that connects to the GPU, the so-called D3D12 device. The device is a physical GPU device. It could also be a virtual GPU device. Of course, if you have a GPU in your CPU, it's also going to be interfaced by a device. If it is a virtual software renderer, a so-called software rasterizer, it is also an D3D12 device. If you are on a virtualized environment and use kind of like the NVIDIA data center virtualization driver, and you're not really targeting one single device, but rather a portion of a single device, it's also a device. It all doesn't matter. At some point, if you are interacting with DirectX 12 and some device of any kind, it is going to be that interface that we're going to obtain in just a second. Now, the device is something that works like everything else in DirectX 12. It is a COM pointer. Now the COM pointer type is D3D12 device. Now there are multiple interfaces of that. I'm always going to take the latest one. I don't know if there's device 11. No, there's only a device 10. So you can see that the device has gone through a few revisions since the history of DirectX 12, and now we are at device 10. Now, obtaining a device is the most simple thing that you can do in DirectX 12, D3D12, create device. One function for all of it, everything is fine. However, the function itself, it has a few parameters, but for the most of the time, we really don't need them. We're gonna maybe use them in a second because it is actually maybe at some point better to kind of like check this, but most of the time, really, you just want to use this function in the most fundamental way on how you can do this. Because if you're using it the most fundamental way, you're basically going to get the device that the user has selected as its primary GPU. So if the user said, all right, I have two GPUs in my system, I have an integrated GPU on my CPU, and I have a RTX 3090 or something like that, and if you set like one GPU to your primary GPU, all of the applications that are kind of like feeding this function in a default way are gonna get your primary GPU. So most of the time you want to do it like that. Now the first parameter is a so-called unknown pointer adapter. Unknown, it's in general just any COM object could go in here. However, not any COM object is actually fitting. Actually only the IDXGI adapter 1, adapter 2, whatever, are actually valid in here. You can ask DXGI to enumerate all the GPUs that are on your system. You can inspect them, get their name, get their features, get their VRAM, and can do some stuff to basically know what GPUs are installed on your system using DXGI. And DirectX 12 is then going to accept this DXGI pointer to create your GPU. However, we're going to provide this a null pointer. Now the next parameter is the D3D12 feature level. Now the D3D12 feature level is going to basically tell the the RP on what's your minimum feature level of the GPU. Now there is something called deact. This is a command that you can enter on Windows plus R, or if you search just on your Windows bar, you can do this. It's going to open up that window, and if you're going to your display tab, you can actually see what your GPU is, and on the right here you can actually see what feature levels your GPU is implementing. If your GPU is modern, it's going to support 12.2. This is kind of like the more modern feature level. And these are kind of like the feature levels on how powerful your GPU is. Actually, not how powerful, but more on like which certain D3D12 API features your GPU supports. Now, for DirectX 12, not all of these feature levels are valid. Normally on DirectX 12, you're just going to use the feature level 11, 11.1, 12.0, 12.1, or 12.2, or that special 1.0.coil, but I don't want to talk about that for now. Now, I'm just going to provide 11.0 in here because we are not going to use too many advanced features. Now, if your application or your engine, whatever you're writing, is going to target GPUs that support like some of these advanced features, you probably want to adjust these. There are tables on the internet that are going to tell you what which feature level means in terms of features. You can also always get your DirectX 12 device based on a very low feature level, and later on check if your device actually supports in higher feature level or supports higher parts of higher feature levels. However, this is kind of like giving you a bit of control about that, because if the GPU can't handle that feature level, then the function is not going to give you a pointer. It's going to return eFail or whatever the parameter is for that H result, and you're going to get a null pointer, and you can prompt something like no compatible GPU found. You cannot run that game or that application. Now, the next parameter is one of these IID PPV args to our device, and that's everything that you need. And hello, hooray, welcome, your first DirectX 12 device created for you. And if I run that application, we're going to get a DirectX 12 device. Here, there it is, device. It has a pointer attached to it. Actually, as you can see now, it has loaded a hell of a lot of more libraries. After I have loaded the device. Actually, if you would take a look at this, it actually even loaded the and some parts of the NVIDIA driver. This is, I think, the NVIDIA driver for DirectX 12. I know, but basically DirectX 12 in the background is basically calling the driver. DirectX 12 is a runtime, a bit of logic, and then it's calling the driver, and the driver actually needs to implement the feature of the GPUs. But yeah, that's basically how it works. Loaded a hell of a lot of stuff. DirectX 12 is doing many things, but yeah, that's not the point, right? So yeah, our device has been created correctly, and we are now able to use our DirectX 12 device 10, which from the hierarchy goes down to unknown, to just a small virtual function pointer table. All right, so now we have our device, and now we can do stuff with our device. But before we're going to do stuff with our device, I actually want to put this in its own dedicated class as well. This is now not support, not debug. This is now basically D3D12, or let's call it D3D, because it's like the D3D renderer that we're going to write here. And then we're going to call this one DX context.h, because it's kind of like the term that we have used. I also want to have a matching CPP file, and then I want to steer my implementation from here. I want to remove the implementations here, call this DX context, and rename all of these to DX context. And then we are ready to roll. What is wrong with you? There it is. Now, this is why I might want to thought that this might be possible to actually put that into a template. Something that I might want to do some research in after the videos that I've recorded, but yeah. Right, so now we basically want to factor out this in here. ID 3D12 device 10, device, there we go. Now we have the device. We can create, no, not rename, we can create the function in here for the device. And we want to basically copy and paste that line of code over there. Now, let's go in here. And basically, what I want to see is if this succeeded, then return true, because it's an H result and something seems to be wrong here. Device is undefined here because it's not called mDevice. And there we go. No by default, of course, false. Now rolling back in the shutdown function, also trivial, mDevice dot release, of course with a dot and not with a pointer, and we are good. Now we just need to include that dx or D3D dx context. Now this is kind of like support stuff. Yeah, I know. Let's maybe separate it like that. And what I want to do now is I actually want to separate it, and I want to check that init succeeds, and only if init is going to succeed, I'm going to continue on my application, and down here I want to then call shutdown so that everything is cleaned up correctly. Now, if I make a breakpoint in here, we should still hit it because, well, it didn't really change anything. All right, there we go. Everything is good. Everything is nice. All good. Nothing special going on here. No live device objects. Actually, I could now provoke some live device objects that you can actually see what happens if I do not release something like that, if I comment that out and continue on. Now we're going to actually have a live device object. We got this live device object down here. You can see the XGVI reports live device objects, D3D12 warning, live ID 3D12 device. Then we get the pointer and the ref count. So now we basically know that something has gone wrong and something that now requires our attention. Yeah, in this case, we can fix this leak quite simple by putting back the comments in here. All right, so now we have created ourselves a device. Now, a device is nice. However, with the device, we can't really do too much work. Now, with that device pointer, we can now basically do all basic setups with the device. However, what we can't do with the device is we can't really render or draw something. If I would try to render something, or call the draw function, there is no draw function. There's also no render function. There's a function create render target view, but there's no function to actually render something on the screen. And this is because DirectX 12 is an asynchronous API. So it's an async API, and the concept of DirectX 12 is that all of the at least frequent calls that you're doing on it are not going to be synchronized. There are, of course, calls that are synchronized. For example, if you're creating resources or if you're allocating memory on the GPU, all of these basic calls that you are doing, all of these calls are going to be done in a synchronous way. So if you're creating a resource, your application is going to block until the resource has been actually allocated on the GPU. However, that's not a problem because creating resources is something in terms of how DirectX 12 wants you to use the API is a concept that you're always doing beforehand. So if you're doing some stuff on the GPU, you basically are meant to, on the initialization of your engine, create all the resources, staging buffers, virtual memory management on the GPU, your own virtual memory management on the GPU. It's all meant to be initialized at startup and then used during the execution without actually then calling one of these blocking API calls. If you want to actually do some work on the GPU, DirectX 12 has found a way to basically decouple the CPU from the GPU side. And actually, it's not even separated on the CPU and the GPU. It's actually even more. It's actually separated on a CPU base and on a CPU GPU base. So actually, what the concept of DirectX 12 is a kind of like a three-way concept. Now, the concept of doing work on the GPU, I'm just going to call this one work now, is the following. You kind of like have the GPU here. The GPU is kind of like connected via a bus. And what you're going to have down in here is a so-called command queue on the CPU side. The command queue is basically a list of stuff that needs to be worked on the GPU. So this is kind of like some work sets that needs to be done on the GPU. Work set, and then some synchronization, for example. This is basically what you're going to do on a command queue. It is just a queue that is basically pushing the work to the GPU and makes sure that it's all executed correctly and executed on the GPU. This might even be directly on the GPU. This is something that's, I think, up to the driver where this is implemented. If this is implemented on the GPU or on the CPU side or on both, most of the time it's going to be on both because you're going to have a queue on the CPU side and maybe a queue on the GPU side, and then it needs to be transferred between each other. But the general concept is that you kind of like have a GPU and you have a queue, and on the queue you basically gotta build some work sets and then some synchronization to synchronize back to the CPU side. Now, what we're gonna do in our CPU side, well, this is like our dumb own simple CPU side, is we are basically building these work sets, kind of like setup, change state, setup, draw. This is, for example, like one work set that we can do on the on the CPU side to basically indicate how the GPU shall do its work. And the concept on DirectX 12 is that these work sets can be recorded asynchronously, independently from each other on the CPU or multiple threads, on a single thread, wherever you like it, however you like it. You can create these work sets and basically build them up, so-called command list. This is a command list. You can do this on the CPU side. You build up these command lists, these sets of work that the GPU shall do. And if you are ready with one of these work sets, with one of these command lists, you are basically gonna give that command list to a command queue, and that command queue is gonna make sure that it's gonna be enqueued on the GPU, at some point executed on the GPU, and then if it's finished and then some synchronization comes into place, synchronized back to your CPU side that the GPU has finished executing. So the concept of DirectX 12, simple. Command queue is a command queue. This is kind of like one single interface. You're going to have like one command queue per application. You have one command queue where you're going to push the work to the GPU, and then you can have multiple command lists that actually going to allocate the work on the GPU side, on the CPU side, and then going to basically record all these commands on that command list, and then it's sent to the GPU via a command queue. And that's exactly what we have, and that's what we want to do here as well. Now, basically what we need is we need another COM pointer, ID 3D12 command queue. That's what we want to have. There might be more. No, there's just one command queue, CMD That is basically what we want to have. And that command queue is responsible for enqueuing work on our device. The device, it's the instance to the GPU. The command queue, it's a queue for commands, or actually command lists, that are enqueuing work to execute on our device. Now, of course, this command queue needs to be created, and now, since this is kind of like associated with the device, it is no longer created by a global function. It is created by calling the device and saying that the device shall do something. The device shall create a command queue. Now, there are multiple functions. Actually, I think what we want to use is we want to use the normal command queue, not the command queue 1, because it is more simple and we don't need all of these advanced parameters. Now, here we're going to see another paradigm of DirectX 12. DirectX 12 really likes descriptor. So the descriptor is basically a struct that describes how an object shall look like, or how a state change shall look like. And as you can see, if I want to create a command queue, it needs one of these descriptors. D3D12, command queue description, pdesc, and some IID PPV args. So IID PPV arg symbol, we already know these. Let's put them in here, my command queue, and that's it. However, what we need to do is we need to describe the command queue. So command queue description, command queue description, make some zero initialization, and then what we need to do is we now need to fill in all of these properties that the command queue needs. Now, the first property that we want to fill in is the type of command queue. So what type of command lists shall the command queue be able to enqueue and execute? Now, there are multiple ways of doing that. There's a few video stuff for DirectX 12 video processing. There are copy queues that are just responsible for copying data between the CPU side and the GPU side, because, well, the GPU might actually be able to do computation work on a GPU, rendering work, while also transferring data between the GPU and the CPU. Most of the time, for example, if you're taking a look in the task manager, if I open up the task manager and go to my performance monitor, and I go to the, where is it? Down there is my GPU. If I go to my GPU, you can actually see that the GPU can do multiple things. You can see that the GPU can do some 3D work. It can do some video encode, which is of course currently doing because I'm recording. And it also is doing some video decode. Can also do some video decode and some copying. Now, the general idea is that these are like all different engines that run independent on the GPU. So NVIDIA has like their own dedicated engine that's doing video encoding and decoding. It might use some 3D work, so like the CUDA cores. These are kind of like the work of the CUDA cores. 3D means CUDA cores. I don't think that I could maybe even open this up. Yeah, you can see that I could change this. But in general, like this is kind of like the load of the GPU in general. So the video encode and decode might use some 3D potentials. If I would stop recording, this might go down. Or might be also because OBS is also displaying stuff, but that's a different story. But the general idea is you can see that it's doing some work and it's doing video and decoding and copying and stuff around. And you have multiple queues for these multiple stuff that work for like video decode, encode, and also like video processing. You can see that there might even be more copy engines than one. I think like NVIDIA has 2 copy engines. Not quite sure of that. But that's something you can always like read in documentations of the GPU vendor, how you should use DirectX 12 if you're programming specifically for an NVIDIA GPU. And this works if you are sponsored by NVIDIA and you're creating a game, you're basically following strictly the NVIDIA guidelines to optimize your engine, your game for NVIDIA GPUs, which might mean that they are not as performant on an AMD GPU, but kind of like a sponsored by NVIDIA, so that's kind of like the point. So, all right, so yeah, that's a general idea. This is why we have multiple of these queue types. There's also a queue type for compute work because, yeah, NVIDIA also supports doing compute and rendering simultaneously. However, what we want to do is we want to use the command list type direct. Command list type direct is used for normal rendering and can also do compute work and also do copy work. Basically, the type direct can do everything. And if you're not writing an advanced engine, it's totally fine to just use direct everywhere. But of course, it's going to cost you performance. And that's all the point of DirectX 12. Now, the next point that we need to fill in is the priority, D3D12, command queue priority. Now, there are 3 priorities that you can use: the priority normal, the priority high, and the priority global real-time. Now, like normal means any normal application. High means this is a game. Most of the time, games shall use high. And there is global real-time. Global real-time should never be used in general. If you're not knowing what you're doing, this should not be used. If you're building like a kiosk-based device that is kind of like displaying some information on a screen, and you're basically having like own cores separated from the CPU that are doing like processing work, and if you're having like a strict resource management and use Windows kind of like in a real-time operating system concept, then this might be something that you want to use. But no, we're just going to use high. That's it. Now we have 2 more things that we need to fill in. We have our so-called node mask. The node mask is a mask that indicates which GPU kind of like is being targeted by that, because a device could also be an SLI device on NVIDIA, and then you need the node mask to correctly specify that. Just put that to 0. If you put that to 0, it's always going to use a default setting. It's going to automatically deduce kind of like the major GPU. You're not going to be able to abuse some SLI features. However, you're going to be able to just use it, the GPU, even if it would support SLI. And this is basically just, if you're not knowing what you're doing, node mask always 0. And then you have some flags. There's only one flag that you can specify: disable GPU timeout. Disable GPU timeout means normally every work that you are doing on the GPU is kind of like monitored by a timeout. And if the work is not finishing before the timeout kind of like runs out, then the work is aborted. It's kind of like a watchdog. But that's something that we don't want to disable. We want to, for a game, not use that. You would maybe want to disable that when you're really just doing some processing on a server application, and this might take longer. Then you might want to disable GPU timeout. But that's something that we don't want to do here, because you can screw things up. And if the GPU then timeouts and there's no like time slot for Windows drawing the desktop, then the desktop gets black and the user panics out and shuts off his computer. There's a magic shortcut that I don't know that is basically going to manually restart the GPU driver with all of the works that stopping all of the work that's going on. But in general, just put it to none, so nothing is going to happen here. All right, so this is basically everything that we need to create ourselves a command queue. Now, command queue, well, we want to of course check that. If succeeded, that, then that, return true. There we go, everything good. I do want to make myself a breakpoint in here, and I do want to make sure that we're going to do release the command queue. All right, so let's see if everything worked out and we have a valid command queue. All right, we hit our breakpoint, so everything is good. And if I take a look in this instance, you can see that we have correct instances in here and everything is looking good. Now, yeah, that's all good. Everything is fine. We got ourselves a queue. Now, what we need additionally to that queue is a so-called fence. Now, what a queue is doing, it is enqueuing work. This is normally the function that the queue can do. It can also do a few more advanced stuff, but in general, if I would take the comment queue point and take a look at what it can do something like begin event, which is meant to just be used internally. It can copy tile mappings. This is some type of work it can do. End event is also not meant to be used. You can, that's not what I wanted to do. It can also execute a comment list. This is something that we want to do. This is like meaning that it shall execute work. You can get like a clock calibration. You can get the description. You can get the device that's associated with the queue. You can get private data. You can get the timestamps frequency. You can query the interface. You can release it. You can set markers. You can set the name. This is something to just identify the queue from other queues. Set private data and update tile mappings and wait for something and signal something. Now, queues in general are quite a fancy thing. A queue can actually wait for a certain fence and a certain value. A fence is a synchronization mechanism between queues or between the CPU and the queue. So between queues and the GPU and between like the GPU and the CPU. A fence in general just is a 64-bit value, and what you can do is you can actually signal a fence by a queue. If you're signaling a fence, you're setting the value of the fence, and if you're waiting for a fence, then you basically wait until the fence gets this value or bigger. And this is basically used to do and synchronize work on a GPU. For example, I could provide a fence and wait for a value, and then on the CPU side set this value at a certain point, and then the GPU would start working. But that's not really the point, because most of the time you just want to start working and signal if the work is done. Because a queue basically it guarantees an in-order operation. So if you are on a queue saying execute comment lists, and then you're going to say signal, then basically what's going to happen is the GPU will start executing the comment list, and as soon as it is finished with executing the comment list, the next element in the queue gets on, and the next element in this case is a signal, which means that the fence gets a new value, and we basically can then tell by asking the fence which value it holds if the work on the GPU has already been finished executing. And that's what we want to prepare for today as well. We're not going to really use it, but I want to prepare it. We want to prepare the fence, the synchronization, D3D12 fence. There are actually more fences, like fence 1. No, just fence 1. And what I want to basically do is I want to store myself a fence, and since the fence is going to have a 64-bit value, I also need to have kind of a way to track this on the GPU, on the CPU side. So fence value, it's going to start at 0. Just very basic. All right, so now what I want to do is I also want to, of course, create that fence. How do I create this fence? Well, we ask our device to create a fence. Now, how do we create a fence? Well, if the fence needs an initial value, we're just going to take our fence value, which is 0, to give it an initial value of 0. Then we need some flags. This is something advanced. It has something to do with like cross-adapter sharing of fences, but we don't really do that, so we're not going to provide any fences. And then we're just going to provide IID PVV arcs to my fence. The fence is such a trivial object that we do not even need to provide a descriptor for it. So yeah, that's everything that we need to do for here. And that's all good. I don't want to provide more information on here, but I might want to put a breakpoint in here. Come on, can I get this one already in here? Yes, I got it in here. So now if we take a look at this, the fence has already been correctly initialized, and that's everything that we need for basically setting this up all correctly. We need a fence, we need a queue, and we need a device. And that's the most trivial thing that we need to get started. Now, what I want to add is I want to add a few helper functions that allow us to actually access all of the data, an inline com pointer. I mean, I might not want to return a com pointer here because that com pointer, maybe we want to have a com pointer reference. I think that's the correct way of doing it. I mean, it is not that clean to have this as a reference because then you could modify it. However, what I could try is a const reference. However, it's a const. The reference is not const. I think maybe do it like that. I think this one shall give me what I want. Is that giving me what I want? This constness is sometimes a bit hard, but that one shall still allow me to get the device and do all of my work on the device. Yeah, that's looking good. However, I should not be able to assign something to that, right? That should not work. It works because it's calling my operator. I should have made that const, but if it's const, the internal pointer is const. Just get rid of it. Maybe now this is, need to be careful that you're not assigning a new value or call release on that, but that's everything. Since we are doing automatic memory management, it's okay. And what I also want to do is I want to provide the same thing for the queue. D3D12 command Q is actually, I don't think that there was a Q1. No. Get command Q, and we're going to return my command Q. That's basically what I want to do. Let's add the reference in here so that we're not going to get copied all over and we are able to access them, basically. Alright, so that's everything that I need for now in my DEX context. Later on, we're also going to need some way of getting comment lists and executing work on a GPU, waiting for the GPU to do work. But that's all something that I want to kind of like delay into later videos if we need them. Maybe we want to do it next video. Yeah, I think we might want to do it next video just for making this feature complete. But for now, it should be enough to basically create all these instances. Alright, so thank you for watching. See you in the next D3D12Ez video. And yeah, I hope you enjoyed. Make sure to like and subscribe and have a nice day. Bye!